Hi guys, I'm Azhar. In this Grasshopper tutorial, we're looking at one of the works by fashion designer Iris van Harpen. So if you guys know her work, she uses a lot of computational design and they're almost impossible to model in a YouTube tutorial. But the one that I think we can attempt today is the epicycle dress. So today we're going to look at how to set this up in Rhino, bring it into Grasshopper, and then use a lot of list management tools to get this dress populated. So let's get started. If you want to follow along with this video, you can use the link in the description box below to download the files. If this is your first time here, make sure you subscribe and hit the little bell so you don't miss any future videos.
All right, let's begin this tutorial. Now, here you see is one example of the dress. Of course, there's others as well that you can find. And, we notice a couple of things. So one is that it follows almost like these volumetric forms, that start off as spheres, but the top one looks more like an onion. Some of these actually look like spheres in the middle. So if we can get these forms first and then try and split these forms up into, these type of fins, that would work out best. So let's go ahead and first figure out these, voluminous bulbous forms. How do we actually begin that in Rhino? So here I am in my Rhino model, and from the SketchUp 3D warehouse, I've downloaded a standard mannequin here, just so that it's going to be easier for us to be able to place these forms. And I've also referenced a photo in here, so if you download the files, you should be able to open this file. And I've kind of approximated, where this dress kind of lies in terms of the human form, so where the waist would be, where the shoulders would be, etc. Of course, this is not going to be perfect, so but if we can just guesstimate it, I think we'll be in a good spot. So I'm going to go to a view that's quite comfortable for me to use. So here's the top view, probably not that one. Here's the front view. I probably need the right view, so let me go ahead, set view right. And here we go. So now I see the mannequin and I see the image in the background. Now notice that when I click, I actually click that picture. So I don't want that. I don't want to accidentally click that picture. So I'm going to go ahead and lock that photo so I don't accidentally disturb it. And I have a layer here called spheres that I'm just going to paint red so that it's just going to be easier for me to see. Now, before we even jump into Grasshopper, it's going to be important to get these volumes in here. So I'm going to start with a primitive. I'm going to start with this sphere. So the center of the sphere could be the origin, right? Now here's something you want to be careful of when you're drawing a sphere. Even if you get the radius right, you don't just want to click. You see how as I move my mouse, this thing rotates. You want to make sure that this is locked in one of those directions. Okay, and it doesn't really matter what size you draw it at. And I'll show you why. Because if I show my mouse right now, if I go to my shaded view and say I take off the mannequin just for now. Look, here is, actually ghosted view works a lot better. Here's the sphere, and I can, drag this up and down using the gumball. I can hold down the shift key and even scale this up or down. So I should be able to take the sphere, and of course you'll notice that, okay, this is not going to be exact. It's more flat at the bottom and pointed at the top. So let's just say this sphere was the one in the middle. You see this guy over here. So I could always line this up somewhere near the middle there. And maybe that sphere is done, right? We can always adjust this later. But let's say I want to do the top one. Now, you're probably going to need a lot more control over this one. So I would recommend when you're dealing with a project like this and you need to modify any of these shapes, I would rebuild that shape. Okay, so when you type rebuild, you get a couple of options, and one of the things you want to realize, especially when you're working with spheres, see how the way that spheres are built in Rhino, right? They work almost across poles, right? So here's a pole and here's a pole. So before I even rebuild this, actually I can go ahead and rebuild it, but I probably want to rotate this 90 degrees so that the poles are always going up to down. You see? Now that pole is up and down, and if I go ahead and hit my F10 key, you see that the control points start to show. Right, so this is important because if this was on its side, it'd be much harder to select these control points. But here I can go ahead in my ghosted view, select these guys, pull them up if I want to, rotate the view a bit, hold down the shift key, and I can start to squeeze these together or pull them apart. It just becomes a lot easier to use And make sure you hold down the shift key, because if you don't hold the shift key, you're going to end up doing something like this, where you are, stretching it in one direction. You want this to be even in all directions at the start, and then later, if you did need to, modify it, you can always just stretch it in one direction. But always start more symmetrically. Again, I can move these up and down and make this as accurate as I need it to be. Okay. Again, we don't want to spend too much time on this part. We really want to get to the grasshopper portion of this. So I've already pre-built the rest of this, which is quite useful. So let's go ahead and just show what that is. But I wanted to, show you what some good practices in building this. And you can see that I made a mistake over here, obviously. This thing should be popping up like this. So it's a good idea that every time you make a change, you just give a good, quick, 2-second revolve and just make sure that everything was lined up right. So if I go ahead and turn this layer on, pre-built spheres, you'll see that I have 1, 2, 3, 4, 5, 6 shapes already kind of estimating the form built in this model for you guys. So if you want to follow along, you just have to turn that layer on, and then that's all you need. I'm going to go ahead and reference these layers in this project. So go ahead and type in brep. Okay, so let's grab those breps from Rhino. So set multiple, and you can either start at the bottom and go down, or the bottom and top and go down, or bottom go up. But just make sure you maintain that order. So I'm going to start at the bottom and go up, maintaining that order. Hit enter. Now I've referenced them. So in my Rhino viewport, I'm just going to go down to a wireframe. Okay, so here it is. So let's rename this. So I'll call this reference spheres, and click the little icon over there so that I understand this is one of my inputs. All right, I have this sphere, and there's really not much I can do with the sphere itself right now except for try and intersect it with some kind of shape that's going to cut it into the fins that I need. Okay, so in order to do that, I'm actually going to draw a line. Like, imagine, you see there's this point here. Imagine a line from this point coming straight out and then going straight up to make a rectangle, and that rectangle is like slicing through this model. Let's go ahead and try that. So type in point, right click, set one point, bring that point into Grasshopper here, and here I'm going to call this base point. So I know what this is. Okay, now from this base point, I want to draw a line. And of course, if you just double click and type in line, you get many different options. But if you're ever drawing a line from a point, I highly recommend just sticking with the line SDL. So line SDL, what it does is it asks for start. Point, it asks for a direction. In this case, I'm just going to arbitrarily choose the X direction. And then it's going to ask for the length. Now, if you don't know what the length should be, I'm just going to go ahead and enter a value. This is a model in feet. So even if the model is 6 feet tall, I doubt the dress is 6 feet wide. So let's just type in 6 and go ahead and put that in the length. And it's hard to see that line over here. So I like to use one of my components, Redline, that you can download, which just highlights any curve components that you've selected. It just makes it thicker on your screen, easier to see. And what I'm going to do with this one is actually extrude this vertically up. So extrude, plug in the line. And the direction we're going is straight up, which is the Z direction. And you'll see that it's gone up by 1 foot because by default it goes up by 1. But I could just plug this 6 in since it's just lying around here and go ahead and pull it up. Now, what you really want to make sure is that it's intersecting through all of the shapes. And you can see over here at the bottom that this bottom sphere is actually dipping a little bit below. So I'm going to grab that point that I had earlier and just drag the point down. And since that point is referenced here into my Rhino file, into my Grasshopper file, the Grasshopper definition moves down as well, which is great. So I can just move it where it's comfortably covering all of the spheres. And there we go. That's it. That's really all I need, because what I can do now is intersect this guy with the shape. Now, you could do this one of two ways. Either you do the intersection first, and then you take the curves and you do the array around, or you can array the rectangle here. I actually prefer arraying this plane first, because say I did want to make a change to one of these, one of these shapes, and I wanted them to be a little bit wider just in one direction, then if I do the intersect and then rotate the curves around, I'm not going to be able to be as accurate, right? It's going to be actually the wrong information there. So in order to stay consistent, I'm going to go ahead and polar array this rectangle here. So if you type in array, you start to see there's a bunch of different array options. I'm going to go to polar array, and the first thing it asks is, what's the geometry you're trying to array? Well, it's this extrusion, so go ahead and plug that in. What's the plane about which it needs to rotate? Now, it seems like it's doing the rotation just fine, so I'm going to leave that empty because I don't want to mess with it. Now, then it asks for the count. And whenever you're covering a complete 360, I recommend that your count is always a multiple of 4. Okay, so here it's 10, so maybe we can enter 12 or a number like that. So let's start with 12. Okay, and as I increase this, I'm going to make sure I always do it in a multiple of 4. Now, things are getting a little bit, confusing over here because there's too much geometry overlapping. I'm going to go ahead and hide the, that image as well that was in the background. And angle here is 2 pi, which is 360 degrees. So I'm going to leave that as is. So these guys that I just created, I'm going to call them my, let's see, intersect planes, right? Intersect planes, even though they're not technically planes. Now, let's take a brief moment to discuss why didn't I actually do planes? Like, Azur, why didn't you just go ahead and cut across this whole thing? Why not make one big rectangle? Well, if I did make a plane that was in this shape, it's going to cut through the entire model, and I really want to distinguish each and every curve around the model, right? I don't want it to cut through the whole thing and then that big round sphere part becomes one piece of fabric. Like, I don't want it to read that way, so that's just a choice that I'm making right here. And plus it avoids me having doubles, because if I did go through the whole thing, then I only need to rotate half the way. I only need to rotate 180 degrees instead of 360. So this way it just makes it easier for me to see what those results would potentially look like as well. That's really the only reason. I'm going to go ahead and hide some of this stuff that we don't need anymore. So now I have the intersect planes and I have the spheres to intersect. So we can go ahead and figure out what the intersection is. Now, if you just type in intersect, you're not going to find the command you want. So you should come up here and there's a tab called intersect, which really has all the intersection options that you would need. Math intersections, physical intersections, shape intersections. So you may be thinking this is a shape intersection, and in a way, I guess you're right. But what you really want to start with is always start on the left and then move right. And so over here, if you reach this tab, you'll start to see, okay, a physical intersection. What kind of two geometries do I have here? Well, I have two kinds of surfaces. Even though one's open and one's closed, they're still both B-reps. And so I'm going to choose B-rep intersection. And let's try this component out. So what is the first set of B-reps we're intersecting? That's the spheres. Go ahead, plug that in. Okay. And what is the second set of B-reps that we're intersecting? Well, that's the planes. And if I go and plug that in, I know something's happened, but it's hard to see. So I'm going to go ahead and hide the planes and hide the spheres. And you see that there has been some kind of intersection happening here. Now, these red lines are actually from my model, so I could just select all of that and hide it. And so now I just see what the Grasshopper script did. And you can see that it started at the bottom, and one of the planes intersected the bottom sphere. Then the next plane intersected the next sphere, and so on. I don't want it to go this way. I don't want to start at the bottom and move up. I want it to stay on the bottom one, finish intersecting with all of the planes, then move to the next one, finish intersecting all of the planes, then the next one, then the next one, and so on. So when you want to do that, whenever you want to hold the geometry and complete a task, you want to make that geometry its own list. So here, each sphere, instead of 6 spheres being in one list, I want to take each of those spheres. And I know I say spheres even though technically they're not, but just, for the tutorial's sake, they're spheres, okay? So I'm going to take each of the spheres, turn them into its own list by using the graph component. So graph tree. So just replace this with this one. And there we go. Perfect, right? Excellent. So now let's see, what can we actually control here? Well, this is what I can really control. This is where the strength of this lies, because this slider is actually the number of fins. Okay, so it's a 12, but I can go any multiple of 4, so I can go up to 40. And you see that it starts to make those fins. but we have a problem here. And it's kind of hard to see in this view. So what I'm going to do is actually use a clipping plane. Okay, so if you type clipping plane and then you click this thing called vertical over here, I can start at this 0 point here and just go along the side and create a rectangle. And what it does is it just creates almost like a section view, right? And if I zoom in over here, you'll start to see that the issue is really that all of these surfaces are going to start intersecting each other. You see, even these two lines, it's kind of hard to tell, but when you look at this on your own computer, you'll kind of tell that these curves can't be made out of fabric because each of these pieces of fabric are lying in the same plane and they're technically overlapping each other. So what I really need to do is alternate them, right? So for example, if I start on the bottom sphere, what I'd probably want to do is start on one of them, you know, keep one, dump one, keep one, delete the other one, keep one, cull the other one. Do you know what I mean? I'm trying to say you want to keep every alternate one and either remove or delete or sift out or dispatch. I mean, there's so many different commands we can use to do this alternation, but the one that I like to use is, well, at least for this tutorial, the one we're going to explore is cull. So when you type in the word cull, there's so many different options that you get. And since anytime you're doing something that's alternating, you know, like keep the first two and then the next three, remove them, and then keep two and then three, remove them, right? Or in our example, you want to keep one, remove one, keep one, remove one. You want to alternate the fins, right? In that case, what you really want to do is use a pattern. Since you're understanding that this is a repetitive pattern, go ahead and use Cull Pattern. Now, again, without getting into any details of what it's going to do, you say, for example, you had, let's go back down to 12, right? If I'm down to 12 and I delete this plane because I don't need it anymore, now I have 12 fins over here, right? So really the 12 needs to go down to 6, because if I keep one, remove one, keep one, remove one, keep one, remove one, and so on, I would have kept 6 of them. So I need to send it a list of 12 and tell it to keep one and then remove one. So notice what you're actually going to be sending this component right now. So what's your output right now? Your output looks like this. So if you send this to Grasshopper, understand how Grasshopper works. Grasshopper always works in terms of lists, okay? So Grasshopper will only move to the next list after it's done operating on the first list. So when you send it this list up here, this list only has one curve. So it doesn't really know how to sort through one curve, right? If I need to send it 12 curves for each of the spheres. So whenever you see this situation happening, almost like someone has grafted your output, you want, instead of grafting, which will move it a layer up, you want to move it a layer down. And the way you do that is you trim the tree. There's too many branches in this tree, so we're going to trim this tree to bring the number of branches down. And go ahead and try that. And you'll see that when you do that, again, now look what's happened. I'm down to 1, 2, 3, 4, 5, 6 branches. Each branch has 12 items. That's exactly what I need. So this is the type of list that I want to send the Cull Pattern component. The next thing is the pattern. And you'll see by default in here it has a false, false, true, true pattern. And what this means is the first 2 items it's going to get rid of, and it's going to keep the next 2. And then it's going to repeat that over and over. That's not what we want. We don't want to operate in a 2-2 kind of mode. We want a 1-1 mode. So the way that you're going to do that is you're going to recreate this thing. And you could do it in here by actually physically typing it in. But we're going to run into some problems if we do that. I always like to do this explicitly. So in this particular situation, I'm going to go ahead and type in Boolean toggle. Right? So Boolean toggle, this gives me false. And if I do a not, okay, a not gate, if a false comes in, a true will come out, right? So instead of just copying this and having one say false and one say true, I can just use the false and reverse it in a way, or flip it to say true. Then I'm going to use a merge component to merge these two together. So false goes in data 1, the true goes in data 2. Let's look at what the output says. Yay, excellent. The output says false, true. And if I, with a simple double click, it will actually reverse. So if I double click, yep, that flips over, which is great, right? So what is this saying? This is saying keep the first one, get rid of the second one, and repeat. So let's see what happens. Now keep your eye over here on the left-hand side. I'm going to go ahead and put this result in the pattern. Okay, now of course nothing happened, but if I select it, you'll see that it selected every alternate one, right? Which is great. So hey, I think I'm done here, but no, notice that you still have a problem. So what is the issue right now? Let me start hiding some of this stuff from earlier, and you'll see that again, that intersection is happening. Look over here, you see all these curves are still intersecting each other. Sometimes it's hard to see, and that's why I also have another component that I use. It's a preview tree component. You can download this as well. And if you plug this into preview tree, it actually takes each list, right, each branch, so to speak, and turns each branch into its own color. So you can tell that all of these curves are on one branch. So are the blue ones, and then the pink ones, the orange ones, the fuchsia ones, and the purple ones, right? These are all on different ones, different branches here. But you see the problem again is that they're all intersecting each other. That's not what I want. What I really need is for them to kind of alternate amongst themselves, right? So if I'm going to send a true, false to the first sphere, I need to send a false, true to the next one. And that way they'll actually alternate even as they go up. So that way they slide into one another, right? Because if you look at the image of the dress again, you start to see that they're never on the same plane. They're actually slightly offset. Like one plane actually goes and nests in between the other two. That's what we want to try and achieve. So the way we can do that is instead of sending it one thing that says true false, what I need to do is I need to send it true false for the bottom one, then false true for the blue one, then again true false for this one, false true false, and then false true. How do I do that? Well, one thing you can recognize is that this data, remember how this data was organized? It was organized in terms of lists, and there were 6 lists. So if I can send it 6 lists over here, we should be okay. Now, the way you can create multiple lists, so you see how you can create a list from multiple items using merge? Well, you can create multiple lists using entwine. Entwine is really useful because you can take this merge guy, put it in here, and let's look at this output. See, it already has 1, 2, 3 lists because it has 3 lists here. But I need 6, so you can just zoom in on this component and click that little plus icon until you have 6 lists. And here we go, 1, 2, 3, 4, 5, 6. Now all that's left to do is populate them. Okay, so remember what that not component did? That not component kind of flipped any true into false and false into true. So I can use that again and flip this guy, this true false, and it should give me false true. And that should go in the second list. You see? And then I just keep repeating. Well, this one goes here, this one goes here, this one goes here, and this one goes here. And there we go. We've built our list. Okay, our tree, so to speak, that has 6 branches. Each branch has 2 items, true, false, false, true, false, true, false, false, true. Let's see how this works instead. So I'm going to delete some of these, create some space over here. And so now instead of this single true, false list going into here, I'm actually going to send it 6 lists. So what this component is going to do is notice that there's 6 lists coming into this input, and 6 lists coming into this input, and it's going to go list by list. So it's going to take the first list from this input, the first list from this input, which is exactly what we need. First do that operation, and then move sphere by sphere. And here you can see that it's worked out a lot better. You see the green one and the blue are alternating, and then the blue and the orange are alternating, or the fuchsia, then the orange, then this one, and then lastly the purple one. Right, so that's exactly what we need, and it may even be easier to see when we increase the number here. So this was a 12. I can go up to 40 now and see what that looks like. Right, you could go even higher. Let's go 64. There, that's starting to look a lot better, and now they're actually alternating in between each other, and they should fit amongst themselves. Now, again, it's a little bit hard to see. So how can we make this a little bit easier? Well, if we turn those curves into surfaces, that surely would help. So if I come over here to my culled list, first of all, let's organize a little bit. So we should give this list a name. So we should call this alternating fabric curves or something like that. So that just we know that we've done the alternating already. And in this case, notice that each list now has 32 items because we had 64. So 64 divided by 2 is 32. And if I do a list item, which means select the first item from each of these lists and see what that looks like, I can isolate that by using this little icon up here. And you see I'm only looking at those curves. And you can see that they're open curves. Right, so you can't make a surface out of an open curve. You actually have to close it first. So the way I can close this curve is if I figure out where the curve starts and where the curve ends and draw a straight line in between them, I should be able to close them off and create a surface. So let's go ahead and try doing that. So grab the endpoints. Oh, and I can go ahead and, well, actually, let's just work on this one, right? So if I hold down Shift, I can see both of these, and I can see that I've grabbed the endpoints. Now I can create a line between those endpoints. Just double click, type in line, and you'll get many options. The one you need is right here. Create a line between 2 points. And if I select this one and this one, you'll see that now I've actually created those lines. But that's not all we have to do. We actually have to join these together now, right? So here's one of the problems you're going to run into. Already knowing what's going to happen, I guess, you need to enter a bunch of curves. Now, remember, components work list by list. So you actually want to send it a list that has, this curve and this curve as one list. Then this curve and this vertical curve as another list. How do we do that? Right? So again, let's see. Alternating fabric curves are here, and these lines are here. Well, you can't just directly go ahead and connect them. What you need to do is if you graph this, right? So here you see how you have 6 lists with 32 items each. If I graphed it, each of those 32 items is going to be its own list, which is great. Look at that, right? So each of these are just singles now, 1 item per list. And if you want to see that, you can open up a panel, and you can see this in the panel that each list only has 1 item. Okay, now I'm going to delete this list item. I don't need this anymore. This is each individual curve. So for each individual curve, I'm going to grab its individual endpoints, which give me 1 line, right? And if I hover over the output over here, look at this output. It also says that each item is in its own list. So there's multiple lists. Each list only has 1 item. That's perfect because now I can use the merge component and merge this original curve with this line, and let's see what this output looks like. And there we go. Look at that. You see, I have now a list with only 2 curves inside it. One is the planar curve, which is the actual curve here from the intersect, and the other one is a straight line that comes from connecting the endpoints. Now, if you don't see this and something starts to mess up, what I like to do is always right-click here and click Simplify. And that should help things line up, just in case they're not lining up for you. Go ahead and join these together. So again, this component is going to go list by list. So it's going to come to this list, combine these, then the next list, combine these, and so on. So what does that give us? That should just give us a joined curve, but they're all closed curves now, which is great, right? Because a closed curve I can turn into a surface by using the boundary surface command. So boundary surfaces, plug this in, and these are our actual surfaces. Now it's a little bit hard to see because I had this button clicked here, so make sure you uncheck that. And again, the red is really hard to see in Grasshopper, so I always use my own components here, which is my brep preview. So go ahead, hide this, put the brep preview in, and that's a lot easier to see. And you can actually see the alternation happening over here, right? How they're nesting within each other. If you don't like this red, you can actually change the naked edge color over here by using a swatch. And you can see now we turn it to white. You can turn it to black, whichever color you like. Let's give it a little more density. Let's see if we can go up to 128. See what that looks like. So double click, make this maybe up to 200, 128 here, click OK, and there we go. That's a lot better. So this is essentially how you can start with some basic geometries in Rhino and start creating a parametric model of this dress. Now what's great about this method is if I show my geometries again, I'm in the wireframe mode. If I'm in the shaded mode, I just see this. Okay. If I go in my wireframe mode again, I have these geometries, right? Look, I can actually change them in Rhino and it's going to update in Grasshopper, which is great, right? As long as that same geometry is referenced. And that's all we need. Now, of course, if you did want to get that edge, because if you look at this photograph, you see how that edge is separate, right? It's almost like this dark outline on those edges. You can go ahead and do that because you have those curves already, right? The alternating curves right here. So you could go ahead and run a pipe command if you want. Of course, the radius is not going to be 1 foot. It's just going to, might even crash on me there. So I'll just put a really small number in there, 0.05. That might be too big as well. Yeah, that's huge. Okay, so 0.01, just for the tutorial's sake. There we go. And I'm going to, again, just do a B-Rep preview. Except this time, I'm going to turn them all black. So I'm going to make a swatch. That is black. Put that as my face color, edge color, and naked edge color. So it just all looks black and you have this black outline on the surface. Even here I could dilute this one a little bit, the actual fins themselves, by using the A component. So if you guys aren't familiar with the color swatch, over here on the bottom you have two modes of the color swatch. You can use RGB or the hue saturation metrics here. So in either of them you have this A value, and what the A does is it's actually the amount of transparency that you can have on this color. So if I plug this in as solid white as the face, this is what you see in Rhino. But if I go ahead and slide this A value down, you see it starts to get a lot more transparent. So you can start to see beyond it, which is pretty awesome. So you definitely have a lot of like display control right in Grasshopper. You don't have to default to that red preview. Well, that's it, guys. So I hope this tutorial helps. Again, you can download this file, and I'll see you guys in the next video. Thank you.
Thanks for watching. If you found this video helpful, give us a thumbs up and make sure that you download any files using the link in the description box below, and I'll see you guys next time.